Hello together. Today we are talking about how to unlock Athlon XPs. To be more precise, we talk about T-Bread and Barton Athlon XPs. And later I will show you how to practically use such modified CPUs in DOS and Windows. Let's start with how it works. First of all, it's important to know that all Athlon XP CPUs with the same die are principally exactly the same, besides the L bridges that are externally on this PCB where the die is on. So, in principle, you can easily create an Athlon XP mobile out of an Athlon XP desktop just by changing the L bridges. And also you can make a Duron out of an Athlon XP by changing the L bridges for the cache, for example. You can also make a multiprocessor CPU out of your Athlon XP. No problem, also possible by the L bridges. So this is the important point. The next point is mobile Athlon XPs have Power Now. Power Now is a feature that perhaps some of you already know from K63 Plus processors, where we already can change easily the multiplier during operation. And yeah, that's in principle it's the same. And last point, what is also important, we can change the max multiplier. So we can not only decrease the multiplier, we can also increase the multiplier. That's very important for overclocking or for mainboards with low FSB. For example, early socket A mainboards. Where in principle no Barton CPU really fits because too low multipliers and too high FSB. And yeah, you can change this, and then you can also use a Barton CPU with more than 2 GHz on for example, an VRKT 133A chipset. So here we have an overview about the L bridges. First of all, the L1 bridge and the L9 bridge, they are just simply connections to the mainboard so that the mainboard you can change something. Beside this, they are completely useless. The next L bridge is the L3. That's very important because L3 is the startup multiplier. That's also very important if you want to overclock without modifying your CPU to a mobile CPU, then that's the right bridge for you. L5 is the CPU type, so there we can configure, do we have a mobile, not mobile, multiprocessor platform, Duron not directly, but there we can in principle configure the type. L12 is for the FSB. In my opinion, not so important. In most cases, you can set this by the mainboard. The L2 is cache configuration. The most of you will just let everything enabled, but yeah, just for information. The L6 is the mobile multiplier, so that's similar to L3, but now for mobile CPUs. To be more precise, it's the max multiplier. The L8 is max mobile core voltage, which is useless on desktop mainboard, so we can completely ignore it. And L11 is startup voltage, in my opinion, also not really important. You can, on most mainboards, just change this like you want. Yeah. The green ones are the important ones, and at least for this mod, and that's why we go deeper into this 4 points. So let's start with the cache bridge. That's the L2 bridge. Here on the first picture, we see this 4 for bridges. It's a bit difficult to see it on the picture. If you have the CPU in front of you, then you should see it better. And on later slides, we also can see it a bit better. For the description here, a line means connected. These two dots mean not connected, open. Yeah, and as you can see, normally all bridges are connected. That means full cache. That's a normal Athlon XP. If you have a Barton, then you can disable half of the cache and make a Thornton CPU out of it. And if you want to disable 3/4 of your T-bread, then you can do this also. And then you have, in the end, an Applebread Duron CPU. Interestingly, you can also switch off 3/4 of the cache at a Barton CPU, which means in the end you have 128 kilobyte of cache. Such CPU never existed, but you can select it here. It really works. I tried it. Yeah, it's a bit funny. It doesn't really give sense, but yeah, you can create CPUs that never existed before. Yeah? So let's go to L3 and L6. These two define the multipliers. L3 for the startup. That's also normally the multiplier for a desktop Athlon CPU, while L6 is the max mobile multiplier. The second one is important if you have a mobile CPU, because now the L6 bridge is the limitation for the fastest multiplier. Now let's come to the L5 bridge. As already mentioned before, this is the bridge where you define which CPU you have. In principle, there are 3 different types that you find in the market. Desktop Athlon XP Duron CPUs, Sempron Athlon MP. Don't ask me why Sempron is the same as Athlon MP. Doesn't really give sense, but yeah, I think it's just for differentiation that the buyers can detect, is it Sempron or Athlon XP, because they are nearly identical. At least at some specs they are nearly identical, so I think that's more for differentiation than for everything else. And you see also the Athlon Mobile, which has also a different bridge configuration. The interesting thing is, from Athlon XP Desktop to Athlon XP Mobile, you only need to change one bridge. The L5-3 bridge doesn't care. You can just ignore it. The only important one is the L5-2. This bridge defines if a CPU is mobile or not. If you close this bridge at a desktop CPU, then that's it, you have a mobile. The L5-1 bridge unlocks the mobile completely. It sets the max multiplier to 24, which is the maximum at all. So in principle, if you modify these two bridges, then you have completely unlocked CPU. That's in principle all that is needed. So the next point, how to connect a bridge. Yeah, this is interesting because it is very small and a bit tricky. In principle, I see 2 different options. You can use conductive silver paint. For this, I recommend to isolate the hole before. So these laser holes from AMD. If you not isolate them, then the conductive paint can go inside and then you can create shorts. So that's a bit dangerous. So I always recommend put some glue or something inside that it is isolated. Another option is to solder a wire over the bridge. That's what I like more. For me, it's easier as I'm good in soldering, experienced in soldering. Yeah, in the end, it's your decision how to do. An important point is there are two different layout types. You see it on the pictures. There's an old one and a new one. You can directly see the new one by these wires that you can see on top of the CPU. Yeah, the old one, you can simply use these shiny dots and connect them. While on the new one, these shiny dots are not connected. Yeah, it's a bit difficult to see it on the picture. If you have a CPU in front of you, then you see these shiny dots are not connected to the bridge at all. It's useless, these dots. You have to connect the bridge itself, and therefore you have to scratch off this coating to come to the copper, and then you can connect them. It's a bit more tricky, but possible. Yeah, and you can also see two examples here. On the left side, the CPU is just modded to mobile and later configured via the L6 bridges. And the right CPU is directly modded to mobile and max multiplier 24. So now we come to some important hints. First of all, there are newer Athlons after calendar week 39, 2003 that are so-called hard-locked. That means the L3 bridge doesn't care anymore. You can do what you want there. It has no influence. The good thing is the L5 bridge still works perfectly fine for unlocking max multiplier and also for desktop to mobile modding. So in principle, if you just want to make your CPU mobile and maximum multiplier, no problem, still possible. I don't know if the L6 bridge still works with this new CPUs. There's one important point. There are some mainboards. In the internet, I mostly read that these mainboards use an AMI BIOS. They start with the max mobile multiplier. And that's a problem, because if you directly connect these two L5 bridges, then your max multiplier is 24. And even with an FSB of 133, your system will not boot anymore. So if you have an AMI BIOS, you have to check twice. Better not directly unlock completely the multiplier, because a board can have some problems with this. Yeah, use an old CPU or use a newer one and try if the L6 modding still works. I don't know. If you do it, please give us feedback if it's working or not. It would be also interesting in this. I only have award biases, so for me it doesn't care, but perhaps for other people. A second point, I recommend to mod desktop CPUs because they are cheap and they are correctly configured for desktop startup regarding voltage and multiplier. I had some mobile processors, and at least on some boards I had problems with them. I don't know exactly why, because yeah, it could be because of a different vCore. Some mobile CPUs want lower voltages and some boards don't support it. This BioStar board from my side, for example, only supports 1.45 volts and more. With less, it has some problems. And also, mobile CPUs have a startup multiplier of 5 or 6. Perhaps that's also a problem for some boards, because that's not a standard startup multiplier for sure for a desktop. Yeah. So another important point, the chipset, because not only CPU is important for unlocking your CPU yourself, it's to use it, it's also the chipset important, because your chipset has to support the mobile CPU, the multiplier change. And yeah, not all chipsets do. NVIDIA, for example, does not. The other ones, the most ones do support it, especially VIA and AMD. Additional, you need to configure some registers. I made a table here for you. Sometimes the BIOS is already configuring this correctly, then you don't need to do anything, but sometimes, at least on my board, it does not, and therefore I had to do this. Yeah. With SES, Ali, and ATI chipset, to be honest, I don't know what you need to change or if you need to change something at all. Perhaps you have experience with the boards. I have only YI and AMD, so yeah, I can't tell you. But in principle, it should work on these boards also. One final point. Also, the board itself must support the multiplier change. Even if the chipset in principle should support it, it's possible that the board does not. One example is the 8-bit KT7A. It's well known, this board, and at least in the first revision, you can read it in the internet, and also I had one, and on this board, no chance. On the first revision, it doesn't work at all. So yeah, even there could be some problem you have to try out. So let's come to practice. Here we have a mainboard with AMD 760 chipset and normal DOS from a floppy disk. So let's wait until the system started. So here we are, and now all we need is PCI set. That's important because we need to change the register setting. For this you need the device ID and the vendor ID. You can, for example, find it out with vpcr edit under Windows XP. So now let's put these numbers here inside. Then the register we want to change, it's 44. Then a mask and the value at the end. So, and now you can see that this register is changed. That's the one for changing the multiplier for the AMD chipset. And now we can use set move and can say, let's change the multiplier to 4. Wait some seconds, and then that's it. Here we are. For sure, we can also change it up to, for example, 15. Wait. So now it should work. So here we are. Now we have 2 gigahertz. And what we also can show is if we, for example, change to 3, that's not supported by this mainboard. And you will see what happens if you try to change the multiplier and it's not supported, or the chipset is not set correctly, then it just freezes. That's it. And here, now the system needs a reset. So the same that I showed you for DOS also works under Windows 98. Alternatively, you can also use a Crystal CPU ID, but nevertheless you have to change the register settings as showed. For Windows XP and Windows 7, you can also use Crystal CPU ID. I recommend it. You don't need to change the register settings, at least in my case. Doesn't care, it works out of the box. Yeah, and you directly see here the original multiplier. You see here this CPU is not fully unlocked. It's with L6 bridge and yeah, not 24 multiplier. And now you can change the multiplier simply by here selecting this, and now you can change the multiplier like you wish. And you can also create a shortcut which makes it even easier. Then you can easily, by double click, change the frequency like you want.